Hey, what's up, Mr. Suda here. Today we're going to be talking about magnetism. Let's get started. Right, so the magnetic force is the force a magnet exerts on another magnet or moving charges. Now, a magnetic force is strongest at the magnetic poles of a magnet. That's the north and the south. Like poles repel and opposite poles attract. So north attracts south and south likewise attracts north. North repels north and south repels south. So if we look at this little picture on the right, south and the north ends of these magnets, they attract each other. And down here, when we have repulsion, the south and the south repel, and the north and north repel. Remember, the strongest magnetic force is at the poles, that's the ends of the magnets. Right, so there are many factors which affect magnetic strength. However, one of the primary factors is distance. In general, the closer two magnets are together, the greater the force of attraction or repulsion is going to be. So in this picture, we have a series of magnets, and they're very far apart, and then they get closer and closer and closer together. As these magnets become closer, the strength of attraction increases. So on the bottom here, these two magnets are going to attract each other much more strongly than these two are going to be up here at the top because these ones are closer, and the force of attraction is therefore stronger. Right, now let's talk about magnetic fields. So a magnetic field surrounds a magnet and exerts magnetic forces. It's strongest near the magnet's poles, and these black-gray shavings around these magnets here are little pieces of iron. Now, magnetic fields are invisible. So if you want to see a magnetic field, you have to use something like iron shavings in order to see them. So we have these invisible fields, and they run around the magnet at all times. So when you sprinkle these little pieces of iron shavings or filings onto these magnets, they create this pattern here. Now, this pattern are the magnetic field lines which surround the magnet themselves. So here we have two north poles of magnets repelling. And you can see when they repel, there's a pattern created in between because there's repulsion. There's no iron filings in the middle. On the right, we have or in the middle here, we have just a single magnet. We can see we have two ends here, a north and a south on our magnet. And you can see that it goes out of one end, back into the other, out of one end, back into the other. Right, so we have these magnetic field lines which go out from a south into a north or a north into a south and create like these rounded lines here. And then out here we have ones that shoot in all directions. So they create like this little I don't know, like kind of like a sun shape here, where you have these magnetic field lines going out in every direction out from the pole. And this picture on the right is the same thing as the one in the middle, except it's not black and white. Right, so these magnetic field lines invisible, but they are present, and we can see them if we use these iron shavings. Again, the strongest is at the poles. All right, what's an electromagnet? An electromagnet is a magnet made from a current-bearing coil of wire wrapped around an iron or steel core. So this is a simple electromagnet. We have a battery here that produces a current and an iron nail, which is serving as a core, right? So when we put the wire onto the battery here, we connect it to this coil, and we put an iron core through it, we now have an electromagnet. All right, so what does the electromagnet look like? What are the pieces that make it up? All right, so first we have a source of voltage that produces a current. In this case, that's a battery. Then we have current flowing through a conducting wire, right? So there's a current, and the electric current runs through this coiled wire. Next, we have a solenoid. A solenoid is just what we call a coil of wire with a current. So because we've taken this wire and we've coiled it around this iron nail here, and we've pushed a current through it from the battery, it's now called a solenoid. And lastly, we have a core that can be magnetized. It's usually like an iron object. In this example, we're going to use a nail. So we have this core that can be magnetized, and when you have a current running through a wire around a magnetized core, this now becomes what's called an electromagnet. So if these pieces are all separate, none of them are magnetic, but when you put them all together, they become magnetic, and we can pick up the paper clips off of a table, right? So it creates a magnetic field, which allows us to pick up metal objects. All right, so how does electromagnetism work? So on the left, when no charge is moving, no magnetic field is being created. So those wires aren't connected, so there's no magnetic field generated. On the right, when the charges move through a wire, a magnetic field is generated. So when we clip these wires together, now there's a magnetic field. So this one doesn't have any magnetic strength, and this one we clip them together, now we have a magnetic field being generated. So what affects the strength of an electromagnet? Well, there are three main factors. The first one is the number of coils or loops in a wire surrounding the core of an electromagnet. Changing the current in the wire surrounding the core of an electromagnet. So if we increase the current, we'll increase the strength of the electromagnet and the electromagnet. And the last one is the type of core that is used. So whether it's iron or nickel, the type of metal also affects the strength of the magnet. But the primary factor here is the number of coils or loops that surround the core of the electromagnet. So we can see here we have 4 bolts here. This one has 50, 100, 150, and 200. And as we increase the number of loops or coils around the core here, we're going to increase the strength of the electromagnet. So this one with 200 loops is going to be much stronger than this one on the left with only 50 loops. All right, let's look at some examples of electromagnets. So some examples include MRI machines, electromagnetic cranes, and maglev trains. Right, so this picture on the right, that's an MRI machine, and you would use that in the same way we would use an X-ray to see inside of our body. However, MRIs allow us to see not bones, but tissues inside the body. So if you injured a muscle in your shoulder or leg, you can get inside an MRI machine and they can show you where that muscle or tissue damage has occurred. Right, down here we have a maglev train. Maglev, we can see mag is magnetic, lev is levitate. We can see this train is not touching the tracks, it's levitating above the tracks. And this is because of the repulsion between the track and the train. Here we can see we have north on the track and north on the train, so they repel, and a south on the track and a south on the train, so they repel. Now by switching these magnets from north to south and north to south, you can actually control the speed, the slowing up and the slowing down of the train itself. So these trains end up balancing on the tracks because of uh, magnetic repulsion, which makes the trains levitate above the tracks. All right, lastly, we have a picture of an electromagnetic crane, which has a very, very powerful electromagnet. You might see these at like a junkyard or like a dump. And this very powerful electromagnet can lift large metal objects such as cars. Right, that's going to wrap it up for magnetism. Thanks for watching. I hope you learned something, and I'll see you in the next video.